And welcome back, students, to our next lesson in information hiding and encapsulation. We're going to discuss today accessor and mutator methods. So first off, let's talk about those accessor methods. So, quick recall. You should always make all your instance variables private. However, you may need to do something with the data in that class object. Special purpose methods such as toString, equals, and any input methods will allow you to do anything new with the data in the object. However, you may encounter wanting to do something with the data for which there is no special purpose method. So then how can you do anything with the data that's in that object? The answer is accessor methods. Right. Provided that you equip your class with the appropriate accessor and mutator methods, which we'll talk about shortly, you can access and change the data in that object. Accessor methods allow you to obtain the data. So for example, in our day 5th try class, the methods getMonth, getDay, and getYear are accessor methods because they're retrieving that information for you. The accessor methods need not literally return the values of each instance variable, but they must return something equivalent to those values. So for example, getMonth returns the number of the month, even though it is stored as a string instance variable. So remember in our program, when we looked at the inside versus outside, one way it is set as a string, the other way it's set as an integer. And generally, when we're looking at accessor methods, we're going to start them all with the phrase get. So for example, like we had getMonth, getDay, and getYear. All right, now let's talk about the companion mutator methods. Mutator methods allow you to change the data in a class object. In day 5th try, these are all the methods whose name starts with set. So that would be ones like, for example, setDate, setMonth, setDay, setYear. All right. In fact, all the mutator methods generally are going to start with set. And when you write your own programs, your accessor methods will be get and your mutator will be set. It's just a common convention to do to help you know which one is which and what their role is. Now, your class definition should provide a complete set of public accessor methods and at least some public mutator methods. So what that means is that you should always allow people access to those variables. So if you have, let's say, a private string name, then you should have a accessor method that allows you to recall name. And maybe you have one that's private int age. Well, then you should have a accessor method that gets age. And then you should have some, of course, like I said, the mutator methods, because you want to be able to call something. Maybe just for this instance, you want to be able to get the name, you can do that. Or you have, like, let's say, one that's name and age, that calls both of them or something, you can do that as well. Now, there are some important classes, such as string, that have no public mutator methods. Let's think about that. Would you want to start modifying the value of a string outside of setting it equal to a new value? No, it could cause some really weird instances here. All right, let's talk a little bit more about these mutator methods. Now, at first, it seems that accessor methods and mutator methods defeat the purpose of private instance variables. Because remember, private instance variables, they're private so that people can't really access them. They're restricted to that class. But now with the accessor mutator methods, all of a sudden we have access to them. Actually, though, if we examine our day 5th try class, this allows us to see that these methods are not equivalent to making the instance variables public. We know that all the mutator methods begin with set, and they all test for an illegal date, and they end the program if there is an attempt to set the instance variable to any illegal values. Now, if they had been public instead of using a mutator method, then you could set a date such as January 42nd, 1930. If you try that January 42nd, 1930 with your mutator method, your program terminates. So this all ties, of course, into encapsulation. This is the principle of encapsulation. And in this diagram here, we have the encapsulation of a class. All right. First thing to note, of course, is a class definition should have no public instance variables. And when we look at the encapsulation, the first thing to look at is this right here. The implementation details hidden in the capsule. So when we start looking at that class, you have the private instance variables, the private constants, the private methods, and the bodies of public and private method definitions. These are the things that are hidden. These are the things that the programmer cannot see. Right? Then we have over here, which is the interface available to the programmer using the classes. So you can see comments, which are really important for things like documentation. You have the headings of a public accessor, mutator, or other methods. So that would be things like what your parameters are going to be, so that way you know what you need to pass. And you have public defined constants. So if you have a constant variable that you need to have, that's going to be accessible there too. Right? Now, of course, that interface is here with the programmer who uses the class. So these are the two things that interact right here. The interface interacts with the programmer, and the program interacts with the interface. And then you have the hidden details, which interact with the visible, and then the visible, which interact with the hidden. And what the encapsulation does, this right here, the encapsulation means it encapsulates everything about that class. Right? Notice the programmer is not part of the class. This is the class. The class has both the hidden and the visible details, but it's divided into these two subsections here. All right, the class has access to private members of all objects of the class. So let's consider the following method of date fifth try. Public boolean equals date fifth try other date, return month dot equals ignore case other date dot month, and date equals other date dot day, and year equals other date dot year. So looking at this, you may think, well, other date dot month, other date dot day, and other date dot year are legal because month, day, and year are private instance variables. Now, normally, this objection would be correct. However, the object other date is of the same type of class being defined, so this is legal. Because other date is another instance of date fifth try. That is why it's legal. Now, in a private definition of class, you can access private members of any object of the class, not just the private members of the class. Similar remarks apply to the method proceeds in the same class. So if we look at our date fifth try class, again, we're talking about the proceeds method. In one place, the definition proceeds, we use other date that month rather than other date that month because we want the month as an integer. Right? Again, we want that as an integer rather than a string. Now, mutator methods can return as a Boolean value. In our definition of date fifth try, the mutator methods tested to see if the new values for the instance variables were sensible values. In other words, did they make sense? Were they real numbers? Were they real dates? If they weren't, the mutator method terminated the programming and issued an error message. Now, an alternative approach to this, rather than killing the program, is to have the mutator do the test but not end it. Because let's face it, if we end the program, well, that doesn't necessarily do us any good because sometimes we want the program to keep running. So instead, the method is going to return a Boolean value. And it's going to make changes to the instance variables and then return true if the values are sensible and false if they're not. So here's our alternative definition of set month. So here, we have public Boolean equals date fifth try other date if month number is less than or equal to 0 or month number is greater than 12, return false because that means it has to be it's either less than January or greater than December because January is 1, December is 12. Else, month equals month string, month number, return true. All right, so let's use that new definition. Date fifth try date equals new date fifth try. System.out.println. Remember this dot 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 just means there's code in between here. Enter month as a number. Int number equals key.next. While date is not set to month number, so as long as it's not this value, System.out.println non-legal number. Try again. System.out.println enter month as a number. Number is key.next. So let's just run this through with some systematic values. So if I take, for example, I do this, I get a number. I go and I punch in 13 because I want to have the 13th month of the year. All right, it's going to check with this while loop if 13 is a valid number. And because it's not a valid number, right, it's going to say not a legal number. Try again. And it's going to ask me for a new number. And it's going to get the next number. So I'm like, well, I'm going to be clever. I'm going to put in 0. So I try putting in 0. It loops back up here. It's going to check that to see if this is a valid number. It is not. So it's going to repeat saying not a legal number, try again, enter as a number. So then I'm going to say, okay, well, maybe I have to play by the rules. I'm going to punch in 6. So then 6 is going in for next int. It's going to loop back up. It sees that this is now false because that is a valid number. And it's going to go ahead and exit that while statement. And that concludes our notes, folks. Until next time.